So now you people run faster. Is a computer A. Configuration is the computer A and requires 10 seconds. Okay. Which has 100 megahertz clock. Its clock speed is mentioned 100 megahertz. We are trying to help a computer designer build a computer B. Now it's another computer B which will run this program in 6 seconds. So your time target is changed 10 to 6 seconds. That means program is same. So here program, that means particularly code. Code is not differ. That means not different because only you have to take the time part. Okay. Second point is that if you notice it, second point, the designer has determined that substantial increase the clock. So the hardware requirement also there. Increase in the clock rate possible, but this increase will affect the rest of the CPU design. Is it true? This increase will affect the rest of the CPU design. Is this true or false?
Yes, sir, because the
It's a
hardware.
harder. Yeah, the clock you are trying to increase the clock rate. It means it is a harder dependent. That means CPU from 3 gigahertz to 2 gigahertz or 5 gigahertz, whatever maybe decrease or increase whatever. The rest of the gem. B2 require, what is the requirement? 1.2 times as many clock cycle as computer A for this program. To increase this amount, what clock rate should we tell the designer to target at least? 1.2 times they have predicted. Then what should be clock rate? It is the 100 megahertz for A. To run B in 6 seconds, okay, and that requires also 1.2 times as many clock cycle as computer A. So for the same program, what clock rate should be done? Tell me.
So 500 megahertz.
500, okay. I don't know how you have calculated, but even I writing. Okay, 500 one answer. Anything else? Any other?
Yes, sir. 500, almost five, like
No,
500.
do. Okay, almost 500. Okay, one good answer. Any other thing, dear students? Any other thing?
Doing it, sir.
Okay, do and tell me.
Sir, 200.
200. So another answer we got it. That is 200. Any others? See, you can check internet or get the answer. That is not the main thing. How do you have solved? That is the main thing for
Sir,
me.
clock cycle is equal to 1 by clock rate.
Okay.
So in that case, we can say that
Clock cycle equal to
Sir,
1 by
200.
1
200.
Sir,
by
200
okay,
megahertz.
200 multiple 200 I got it, na? So double
Yes.
like, okay, let's see. Clock cycle to clock
1
cycle
by
or
clock rate.
clock cycle rate, CR, which one?
Sir, 1 by clock rate is 1 by 100 megahertz for clock cycle.
1 by clock cycle, okay.
So we multiply that with 1.2 in order to get the clock cycle for B.
Okay, then how much you're getting?
So I'm calculating that only, sir. That is the portion I'm calculating actually right now.
So you're getting approx.
Yes, sir.
Approximately you're guessing.
It's approximately guessing to a great extent.
Oh, you guessed, I think, this value. Answer is very close to the your answers. Then why people are guessing? You should answer it properly. Any idea? Let's see how to solve it. The solution is like in this way. See, the CPU clock cycles by the clock rate. See, due to the time consumption, the solutions I have written here. Answer is 200 megahertz. Okay. The CPU clock cycle, it is given 10 second. It is mentioned. So clock rate by, it was in gigahertz, megahertz. So it is converted in hertz. So cycles per second is 100 already mentioned. Okay. So the clock cycles for CPU A, this clock cycle for CPU A, that we mention like in this way. Someone is creating the noise in the classes. The understood by you?
Yes, sir.
That it is already mentioned the first clock cycles for the CPU we have computed is found like in this way. Now CPU time B also is a 1.2 times the clock cycle C. So you just put this value here and it's 1.2 times that's the clock cycle rate, and then finally you have to find out the clock rate divided with the 6 seconds. So the answer coming to 100. I think it's very simple mathematics, just CPU time clock cycles by clock rate. Okay. Now you uh, just for the sake of new chapter, because we will start today new chapter that is very important for all of us, so we have to go very. Suppose we have a two implementation of the same instructions architecture. So same instructions architecture, that the IS is same. Maybe my IS is same means their instruction format, number of instruction, all these things here. So it does not matter for me what to count. A machine A has a clock cycle time 10 nanosecond. Okay, and CPI is 2. Okay, is 2. Per instruction is 2.0 for some program, and machine B has a clock cycle time 20 nanoseconds and CPI seconds per instruction 1.2 for the same program. Okay, so that CPI only differs and the time also you found that doubled. Which machine is faster? Machine A or machine B? Same clock they are running.
Sir,
Sir,
A is
machine.
faster.
Yes, sir. A is faster.
A is
Yes, please.
faster.
Faster.
A is faster. Okay, let's see
Yes,
again.
faster.
So A is 1.2
And
times
1.2
faster
times
than
faster.
machine B.
Yes.
That's I have written like in this way. That are instruction, number of instruction plus instruction clock cycles for per instruction. So that is the CPU clock cycle. This is a normal formula I have written. CPU time, CPU clock cycle multiplied with the CPU clock time. And no, it is a I.20 for the clock cycle and 10 nanosecond for the section. Say like section B, it will find same thing and time for them 2.0 seconds. Okay, here 1.2, here only 2. That is the cycles per instruction. So you got these two value. Now you know execution time always reverse of the performance. So that's why A by B here with a B by A. You got this point? Because execution time, that means our performance always the inverse of execution time. Is it clear or not clear? So that's why A by B inverse of this one. So you are getting 1.2. Is it clear?
Yes, sir.
Yes, sir.
Now tell me this one. Now program also differs. Here also code sequence I have given. That means instruction class A and instruction count for A, B, C. That means code sequences are there that which will run for the machine A and machine B. Instruction class A, B. This is not the different class, but you say segment of the code. Okay, so compiler isn't trying to decide between two code sequence because it generally happen two code is submitted for the same program maybe. I told na clever coder is very good or do is performance oriented or not. You can check it here. Now designer is trying to decide between two code sequence for a particular computer. The hardware designer have supplied the following facts. What following fact? Instruction class A CPU for this instruction class is 1 and for B is a 2. Okay. Now for a particular high level statement, the compiler writer is considering two code sequences that record the following instruction count. Code sequence A, one has 2A, 1B and 2C, and like in this A, here is a 4, 1, 1. So I can say total code for code sequence is 2, total 2 plus 1 plus 2. And for here 4 plus 1 plus 1. So here is the 6 total code sequences, or is the total 4. Okay, that we in our hand we have. Which code sequence executes the most instruction? Which will be faster? And CPI for each sequences. Tell me. Any idea?
Code sequence 2 has most instructions.
So that we have written here, this formula, this is the CPU clock cycle for entire program. I have a total number of clock cycle for each sequences. It's just like a 1, 2, 3 I have mentioned, and therefore 2, 1, 2 I have specified their code lines. The one first sequence, second sequence, third sequence. And this is their, I think the number of instruction 2, 1 and 2 that is mentioned here. 2, 1, 2. That is the code sequence instruction counts 2 and 2 for first, 2 after 1 clock cycle, second will start. After 2 clock cycle, I think third will start. So this is the actual sequences as mentioned. That's why first, second, third, first, second, third of the first clock cycle. After second clock cycle, and this is the third clock cycle, and this is the their code sequence I mentioned. So total cycle for each of the codes we have found, that is 10 cycle for the clock 6 cycles 1, and this for 9 cycle for cycles 2. So already we know the 6 for instruction execution 2 and 5 instruction for this one. Even it is a more number of instruction, but notice there at first clock cycle the number of code they are executing is differ as the second and third correspondingly. So CPU clock cycle by instruction count. So CPU clock cycle how much require? Well, there's a 10, and clock cycle instruction count I found, so it is a 2, and CPU clock cycles for this one is 9 and instruction count is 6, 1.5. So like in this way you can find out that the instruction count, even it is more, even it has a number of code is more, okay, but if you compute the even number of instruction is more, but it require less time. The utilization of the clock cycles in earlier and later, and the number of instruction count in the program in the sequence is very important. Okay, so that's up to the performance related problem. Whenever we will solve, you have to find out that performance related problem may come in this way. Okay, any other query from your side regarding this problem? I will upload this slides to your Moodle also for your, as you told that you need some revision. So I will upload it there. Okay.
Yes.
Any doubts?
No, sir.
Okay. So now we are moving towards our new chapter, and that is very important chapter and my favorite chapter. So you can expect a lot of good question from this chapter also. Okay, and that is we can say our memory management. Very important chapter. Is this available visible to you, Myro? The name is
Yes.
Myro.
Yes.
Okay.
Yes, sir. It is very.
Okay. So I already told that in case of CPU, generally you found that earlier I have mentioned there is a one CPU. There is a memory we call cache, and this is our main memory. And rest of the part here I am written secondary memory. CPUs directly can access the data from main memory. CPU can also access the cache memory, and there is the content of cache and main memory. Here I have not mentioned CPU register. That is, very important part of this design. Okay, and main memory, control secondary memory. This is the basic computer architecture. Sorry, computer organization of the memory. Now the question is coming that earlier days cache was not there. This was not there. This is the first fundamentals. Earlier days cache was not there. Then what is the significance of cache? This come. This is the first question, why this is introduced. Second thing, since our concept is stored program concept. Stored program concept. Introduced by whom?
Von Neumann.
Okay, finally. Okay. You just remember this person name Actually, this is the invention for this person, and nowadays you are enjoying your desktop or laptop. So stored program concept introduced by von Neumann, and after that also another revolution is the RISC, that is load store architecture. It's a von Neumann formula, but it is a tuning, you can say, the load store architecture. Now my question is coming there, why cache is introduced? I think the story I have already told. Now more detail we will find it here. Can you recall the story? Hmm?
Or get information like you didn't tell any stories, you just told us the features of cache, sir. Like it's faster than main memory, sir, and its speed is very
So
close.
one is the faster than main memory. My writing is visible to all of you.
Yes, sir.
Actually,
Yes,
I'm
sir.
using new tool Miro. That is a good tool for online open access. So I don't know whether clear views coming is okay. So faster than main memory. That is the good concept. Second, any other?
So we can
Sir,
quickly
बोला
retrieve
sir.
data.
So very
One by
close to the
one.
speed of the CPU, sir. The CPU speed and cache speed are very
Very
close.
close. The word does it mean? What does it mean? Very close.
Like slightly lesser, sir.
Huh?
Like cache speed is only slightly lesser than the CPU speed, sir.
You have cache speed. You are telling that cache speed is very
It's slightly lesser than the CPU speed, sir. Just slightly lesser.
slightly, so not like in this. The huge band gaps are there, but comparing main memory, you can see it is faster. But like CPU's clock speed, it can't achieve. That we can't point out. Are you getting my point? That you
Yes.
can matter. So very close in the sense that the physical distance does not matter for the computer organization architecture. Very close. I think. Okay, CPU register is very close to CPU. In terms of interconnection, if you physically position, if you are mentioning. But that should not be our target. Our main target is that proximity is always a must good criteria, that time to propagation or time to data transfer will be very less, but that will not be that is very negligible in terms of semiconductor based memory. Are you getting my point or not? So that's why I am not getting this one. But number two is faster than main memory, but it follow the principle of locality reference. This is the main concept. Earlier in computer was not there. Now it is come. It is clear. Principles of locality reference. Now, what does it mean? The principles of locality reference. I told one story, two situation. One is that every day you meet with friend in झूप्स. आप लोग झूप्स बोलते हैं ना इसको?
Yes, sir.
Yeah, आप लोग का favorite झूप्स, whatever you are missing. In our language, bush. No problem. So every day at 6 p.m. you two friend meet at jobs. Okay. Sometimes it happen that if the person is not here, what will be your main search? Either you will go the ATM part, either you will go the nearby bushes or sorry jobs, whatever you say. If these two threes are available, see, suppose there is no mobile communication. No, this is the one termination I'm using. Sir, through mobile, we can directly call him, will come. I know so many options are there. But for timing, just I'm telling that, suppose that no mobile communications are there. Okay. So in these cases, physically only you are meeting. That's why the point I made, a physical point I mentioned, physical meet. So there will be no technology or gadget meet something. Okay. Physical meeting. So now in these cases, you just mentioned that the person, if it is not available, you will search it nearby location, ATM or nearby bushes or something else. Even even if some friends are there, you will ask which is very close to the bushes, whether he has come or not. This is the our common phenomenon. Is it clear? Second phenomenon will come that you are searching for some person. Okay. Now, not such person. I told that is a fact of calculator that after each class you can go to the hostel and you can fetch the calculator and do the tasks. Again, you go to the hostel and submit. Again, next class, if required, you will fetch. Otherwise, you will not fetch. This is the one thing. Otherwise, this device may frequently require for this time, or that it will required in the during the exam. It is required the calculator frequently. Generally, you people never doing these things. Whatever you are lending from others, asking, requesting others to lend him his calculator during the examination. But fundamental right is that if it is required fundamentally, you keep with you this calculator instead of lending or instead of going hostel and turn it back. So two situation you will come. You will get two situation. What are the two situation you will get? First of all, one situation is that you will get uh, mostly two criteria. One criteria is that either you will frequently access these things, frequently access the dot library. It may be page, it may be your uh, calculator, like in this. So even also in clothing also, those clothes you are very feel comfortable and regularly you are using, you keep it with always in the front of your cupboard. It happens. Two is that nearby location. Am I clear? You people, generally these two things are very important. Frequently access or nearby location. These two phenomena generally works in our brain. So scientists thought that why not, when CPU is like me and he needs some data from the main memory frequently, and every time he goes to the main memory, takes the data, computer tasks again, for next time he goes and take, like in this way happen. So what happened that CPU don't know whether this will be frequently required or not, but suppose somehow some way CPU came to know through the scheduler. Actually, this is the task of the operating system scheduler. Through the scheduler, he understands that this page, suppose one page X is present, some content in the main memory, which will be required frequently. So CPU will bring this page in some location from the main memory to X in some location and frequently try to access it. Are you getting my point? So this will solve the process of frequent access because it is very slower. So he is introducing a fast memory. So it may be happen generally now you people are use 8 GB, and now we are expecting that our cache should be at least how much now cache should be 2 KB, 4 KB, or maybe 16 KB, like in this way coming. So the interesting fact that if it is 8 GB, why cannot make 8 GB RAM or 8 GB cache? Any idea why we can't make 8 GB cache?
Sir, it's expensive.
That is the main reason. Due to the expensive, we can't take it. It's a good point. So this part is due to the expensive, we can't make it. The technology differences. But though nowadays, when technology invented, after some time decrease and the size will automatically increase. Somehow, someday, 8 GB RAM now you're using. Sometimes 1 TB RAM also may be using in your desktop. It will come. Earlier days, in our days, only 5 or 6 MB RAM also there. Okay, no problem. So it is coming KB.
Sir,
Yes,
sir, why this is expensive, sir?
not getting your point.
Sir, why is the cache memory expensive?
Reason is the expensive. First thing is the expensive. The technology differs. So if we increase the size into MB or GB, I think the cost of the product will be more than 1 lakh, and you people can purchase. So the commercial viability also restrict the engineer to think the market status. Do you
So in
get the
that
point?
case, if they are expensive, like very expensive research-based laptops, for example,
Yeah.
sir, could they have higher caches, like
Yeah,
a GB
higher,
cache?
not more than memory. It cannot be happen. The logic is that all the pages sometimes when required, because cache always takes the frequently accessed page only. If suppose a process running in the program, maybe one movie is running on the program, or maybe a song is running, maybe you are running a some program where have only 100 page data. Here, just for time being, you consider each page is a one individual location. For time being, you think so 100 locations are there, but among 100 location, all the locations are not frequently required. Only those pages are frequently required. Only those pages will come in the cache. It does not be, should be always sequential, never required. So only this point, remember, frequently access required, those pages will I would take care. So cache size, always remember, cache size, it should be always less than main memory size. It does not require, because when all the pages of main memory require all the cache size, then what is the purpose of the main memory? Not required. Even also nowadays, cache are splitted. Multi-level cache has introduced, multi-level, or you can say multiple. So we are considered the multi-level cache. Then one cache like CPU registered in the CPU itself embedded within the CPU. Within the CPU it is embedded, that is L1 cache, and from outside L2. Then again more cache L3 will be there. It means that CPU first search the data in the cache L1, which is very close to him inside of on chip, physically also, and speed also very high. If it is not found in the L1 cache, then it will go to the L2 cache. If L2 cache data is not found, then it will go L3 cache. If L3 cache is not found, then finally it will go main memory, and corresponding all the memory location where required, it will be updated. If it required to keep L1, it will keep L1, either L2 or L3. So this is a multi-level cache. For time being, we are not following the multi-level cache. Just time being, we are just following, instead of multi-level cache, we are just following the purpose that how only single cache initially introduced, that single cache we will follow. Okay, so again come to the point, that is our CPU, this is our CM, and this is our PM. For time being, you just remember Prime Minister very far away from your location. I am not staying Delhi, so compare the icons. Chief Minister very close to you. True or false? The power or restriction Prime Minister and CM is not same. You know, his power is entire
Yes, sir.
country. I remember this is a cheating policy to remember the difference between all these things. There is no official statement. Complete unofficial, illogical, baseless assumption, but sometimes it will help you to understand the power as well as the size of breathing. Clear? So that is our cache memory. We consider as a CM. In local level, it is very high. If you consider West Bengal CM will be more administrative powerful. Even Prime Minister will come and go, but he can't interfere all these things because CM presence are mandatory. True or false? Administratively. So I think practical all these things we are implementing actually. So Prime Minister have all the right, but local level he is fine. So this concept we are mentioned locality. Clear? In locality, and this is the principles of locality reference. So those two cases when a single page is frequently required. It which case happen? Suppose you are writing for some program. Within the for you are writing some I equal to j or something statement they are writing. And you know, for those for statement, every time this will be executed. Am I correct or wrong? Every time it will execute. So every time content of I will be content with j. Why not I will keep the j pages in the memory itself? So this type of thing introduced in looping structure, and it will be introduced. So that is called temporal locality reference. Temporal locality reference. Clear this point? Those pages, those location, those operand, those memory variables which are frequently for the CPU, accessed by the CPU, will keep in the cache for temporal specifics. When it is not further required, it will be replaced to the cache memory. When not required further, only frequently accessed, it will stay in the cache memory. So that's why when to decide and what to replace the policy we have to decide. We'll discuss very soon. For timing, you just remember this is temporal purpose. That's why it is temporal. Because temporary you will stay, when not required, get out. So temporal locality reference. Second is that now in the for loop also, it's just still you need some, suppose AI equal to BI plus CI. Do you get the point? So After I equal to 1, next location must be 2. So our memory tenacity is that after this location, nearby location will be the most favorable one. That I told the story earlier. Most favorable cases. That means the pages required for the next instruction, it must reside close proximity to the previous location. If previous location 100, it must be 99 if I consider 1 byte addressable memory, or maybe 101. The chances will be high. So CPU when fetch the data, if some block of data is required, so they will take entire block to the memory if size permits to the cache. If cache allowed to take the entire block, they will try, because they know after this location is nearby location has a great chance to be accessed. And these things is called spatial, SPATIL, spatial locality reference. Got the point? So we found two type of locality of references. Clear? So we found here temporal, and second point is spatial. Any doubts? Any query regarding these two?
Sir, can you please
Special once again, sir.
explain? Yeah.
One by one, one by one. Just anyone tell me.
Sir, could you explain the spatial one once again, sir?
Okay. So spatial one, I'm telling that uh, first of all, the screen visible still now to you.
Yes,
Yes,
sir.
sir.
Okay.
Yes.
In the array access, what happened that in array particular, it is a contiguous memory location. Okay. Concon, you are there.
Yes, sir.
Okay. Next question to you come very soon. So in temporal memory location, you find that now you are accessing this location, suppose. And there is a chance after this you will access this location. I don't know. Maybe it happened that in this program, after this condition, maybe you have to go this location. That's the tenacity. But what happens when the frame by frame data is fetched from the memory location as per the size of the cache? When you are accessing this location, CPU in cache memory, they will try to go to the next VSN because 100 location currently you are accessing. After that, your next location will automatically 101, or maybe in decreasing 99. The chances will be their page will be very near to the location. So generally we go for the ascending order or increasing. So after 101, the possible location will be 101, 102, particularly this one, where the page next data should be present, next instruction, that program or next data, which is required for the CPU, there is a chance to be present. That is the main thing. That means it generally happen in contiguous location of the memory access the array. In case of array structure, when you know the contiguous locations are there, so when you are accessing the array, cache will try to fetch the entire array if possible to its location, because cache know in array the memory location contiguous, and after that next location to be fetched will be understood by easily by indexing. So that is the feature. So even also in a single page, not array, you are accessing suppose location number 100 and X data is there in the cache. Now, what will be the next pages to be fetched to the cache? Apart from the policy also, you just remember that it will search to the location, nearby location of the cache where the pages should be present. So tenacity to search, otherwise CPU by default, which will be searched? By default, it will be searched the next location to be executed. That I am telling spatial locality. That means it will go for the nearby location of the currently execution location, not jump after last or first, not like in this way. Just it will go to the currently nearby current locations, nearby locations. So that tenacity we are forcing to the case to maintain, and that is called spatial locality reference. Is it clear?
Yes, sir. So basically, it's physically going to the nearest location, sir.
Yeah, it's a physically it will search for its nearby location. Okay. Now this term is clear, memory, main memory, or we are in still Miro scheme.
Yes, sir. Now it's clear, sir.
Okay. Now we are moving to the slide. This slide is visible. Okay. So that's I mentioned levels of memory. Level 1 generally we mention registers. It's a type of memory in which data is stored and accepted that are immediately stored in the CPU. Most commonly used register is the accumulator, program counter, address register. Can you tell me one addressing mode where directly accumulator is present? Addressing mode.
So,
Sir,
so direct,
loading, sir.
sir,
Which one?
Loading.
sir,
No,
indirect
no,
address.
no, direct addressing mode, you are accessing some memory. It should be
So
always,
risk,
yes.
same risk.
I would like to tell that one addressing modes are there which by default mention that we are using accumulator. Sometimes in case of stacks also by default it will mention it is a stacks. That is that when
Yes, sir.
you are doing, yes, tell me the name,
Sir,
Concon.
immediate accessing. Sir,
Yeah,
immediate addressing mode.
immediate addressing mode is a different. Any other mode very close to immediate addressing mode?
Sir, direct.
Sir, register indirect.
No, 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 no. Addressing mode not clear to all of you. I think one mathematics will study in that addressing mode very soon.
Sir,
After
sir,
this Monday I will start one mathematics from addressing mode. I think that time it will be clear. Okay, for time being, I am telling that addressing mode notes I have given in the website. So you go through, that means this Sunday, Saturday. So Monday I will discuss one problem from addressing mode. Is clear? I think until unless no mathematics, so your from brain will not clear. It is a immediate addressing mode. Directly accumulator or stack registers are mentioned. If you use the push, if you write a pop, push 5, pop, where it will push or where it will be stored. By default, in case of stack organization, it will directly mention stack. When you write add a, you mention a will be added to whom? Add a will be added to whom?
so the accumulator, sir.
A. So it is immediate, it is already mentioned. I am not specifying it.
Yes, sir.
Okay. Or at 5, not memory location, direct at 5. So accumulator. So that is the immediate addressing mode. Study it. Now, it's a type of memory in which data is stored the level 1 register. Sometime you found that level 1 or register also means L1 cache, you can say consider. Okay. But for timing, we consider the L1 is the register. Then level 2 memory is the cache memory. Okay, multi-level cache I am not mentioning here. Sometime I will solve some problem with multi-level cache also. That time you will consider multi-level cache. Level 3 is the main memory and level 4 was the second memory. So that's I consider if you mention this is a CPU, within the CPU some registers are there. Am I correct? Within the CPU registers are there. So this is the register part. Now CPU, if data is not present register, it will go to the cache memory. And also if cache memory data is not present, main memory. And after in the main memory not present, then it will go secondary memory. So this is the hierarchical way it will searching. No parallel searching. Parallel searching also possible if there is a multi-level cache. Sometime parallel searching. So try to understand the question paper very properly during your examination, that whether there is a chance of parallelizing or whether this hierarchical. So this is the actually hierarchical structure. This is the hierarchical structure. Got my point? But sometimes parallel processing of the L2 and L3 caches is possible. So during that study we'll do it. Okay. And you know main memory. The concept always remember that the data present on the cache memory is the subset of main memory. Am I correct or false?
Yes, sir.
Always remember. The content present in the cache memory, everything present in the main memory. So main memory is, you can say, cache memory plus extra. Extra size is huge. So never confuse that cache memory and memory are not that. So CPU when updating the cache content, then what will happen? Suppose a page X is there, you feed the X. Now X is X plus 1. Whether it is reflected here, will it be reflected here? So that time we have to maintain the data integrity or consistency both. So in data integrity issue is a very critical issue in this multi-layer architecture. Same thing in case if you are updating main memory and finally you are not storing in the secondary memory, the result you will not find out. So this is the one issue you just remember. So in the case
What is
design,
the secondary memory, sir?
same thing in the main memory. Main memory, some pages are coming from the secondary memory. The secondary memory contains all the contents which are present in the main memory. But sometimes additionally main memory you are writing some program and doing some main memory. Until unless you will not save, the content of the main memory will not be there in the secondary memory.
Okay, sir.
So when you are taking a page from secondary memory and now you are operating from the main memory, because CPU will never deal directly with the secondary memory, always deal with the main memory. So you are accessing main memory. So now you are changing the content of the main memory. Then what will happen in case of secondary memory? So unless this page is removed from the main memory, you should remember the data integrity should be there. And that's why there is a two concept, write back and write through policy, that I will discuss very soon. Just remember write back and write through policy. I will come to the point later. Now in the case design, remember size is very important. Mapping function, that is another very important discussion because most of the question from this semester may come from this one. So mapping function very important. Even replacement algorithm, that means in the cache memory I know the page is limited. In the cache memory maybe here 4 pages are there, main memory is that there may be 16 pages are there. So at a time only 4 pages will come. Among 6 page days, suppose that the 6 pages are there and here is a 4 pages, so at a time only 4 pages will come. Which 4 pages will come, that is the one policy, that is mapping function will decide in which 4 will come, which 4 page will reside. And also when you are doing updating, some page will replace, some will come. Then also write policy is very important. Sorry, replacement algorithm, which page will be replaced, which page will be replaced. Got the point? So which page will be replaced, they're defined by the replacement policy, and which page will be loaded, they're replaced by the mapping function. This are clear, these two algorithm. Mapping function indicates that which page will be loaded in which location of the cache. Is it clear? Which page from the main memory will be loaded to the, obviously those pages which I am required, which is required for my calculation, which is required for my purpose, that will be loaded, which require demand by the CPU. That is the obvious point. But in which location of the cache it will be loaded, that depends upon the mapping function. But replacement algorithm will define a help us when you are loading the pages for particular location the cases, it sometimes happen that that location not occupied by other pages, so it should be replaced. Or which page it will replace, either it will replace or it will go to the next location. That depends upon the replacement algorithm. Is it clear, these two function, mapping and replacement?
Yes, sir.
Is it clear? And also write policy, that I told two type of write policies there, write back and write through. So one policy is the write back, another is the write through. In write through policy, you just remember cache and main memory both are updated together. Suppose one data in cache memory, x was present. If you make x equal to x plus 1, same thing, it will be x plus 1. What will the problem tell me in these cases? Because main memory is slower than the cache memory, you know, but their latency will be here elapsed, or you can say used, or you will utilize many huge number of latency clock cycles in the cache memory. In the cache memory, huge number of clock cycles will be utilized. Due to the reason, that means why? Because suppose cache memory require 2 clock cycles to update, main memory require maybe 5 clock cycles. So in this policy, total I think 5 clock cycles will be essential, because within the 5, this and this both will be updated. Am I correct or wrong?
Yes, sir.
In write through policy. But if you are doing write back policy, in write back policy, during the execution, the cache will be updated. Only cache will be updated. Main memory will not be updated. So initially you will get very high speed. When the page from the cache will be replaced, that time only it will update the location. So initially 2, and if you replace the place immediately after the updation, that additional 5 per clock cycle, so 7. So in write back policy, the worst situation will come if after update the cache, if you just replace the page. Are you getting my point? If after update the cache, if you replace the page, someone creating the noise, please mute your audio. Are you getting my point? So in write policy, if the worst scenario, try to understand, if you are not replacing the page at this moment, so write back is very good for you. Every time the cache will come updated, and only the latency is recorded only 2 nanoseconds for only updating this thing. So there is a huge saving of the latency, or you can say the time in write back policy. Once the page will be replaced from the cache, then it will be updated to the main memory during the replacement. That time 5 additional required. So the additional time will come when you are replacing. So if the page is updated frequently and you are not replacing at this moment, so no need for the additional burden. But in write to policy, if you are updating frequently and you are updating the main memory again, so that time 7, am I correct or wrong? Every time 5, sorry, every time 5 latency will recur. So which one is good? Write back or write through?
Right through.
No, write through is overhead because
Right
every
back.
time you change.
So what is right to, sir? Could you explain what? Just say right to in brief once more, sir.
I am telling that in write through policy, for every updation, cache memory and main memory simultaneously will be updated.
Okay. And in
To
write
main
back, only cache is
why
updated.
updated? First, just tell me why updated? Because to maintain the data integrity. Otherwise, data updated data will be not there in the main memory, so data integration issue will be there. That is the reason. So every time cache memory and main memory will be updated. So if cache memory require 2 nanosecond and main memory require 5 nanoseconds, so 2 plus 5, how much? 7 nanosecond. But actually in write to policy, within the 5, I think cache 2 and that main memory updated. So every time 5 nanosecond is required. It is not addition because write through both are updating same. So maximum was main memory is 5. So 2 plus 5, 7. Is it clear? Sorry, 2 within 5 both will be updated. Is it clear?
Yes, sir.
But in write back policy, only the cache will be updated. In the write back policy, only the cache memory will be updated. No updation there in the main memory. Main memory will be updated when the page is replaced from the cache. Due to his page requirement or other pages, it will be replaced from the cache. That time main memory will be updated. So that additional time will recur only once. But once the additional RAM, that's 7, the worst scenario will come if you update the pages just now and after that you are trying to replace the page. So that time it will be the very drawbacks for the write back. Am I correct or wrong?
Yes, sir.
Because earlier 5, now it is becoming second. But general cases, write back is mostly used because only the replacement, once you replace it, that time you just changes the only once time main memory writing. So multiple main memory writing can be avoided in case of write back policy, except the worst cases. What is the worst cases? You retain the cache and after reading the cache, you are immediately replacing the pages. Only that cases only this will happen. Otherwise, write back is more advantage. True or false?
Yes, sir.
Because we can avoid multiple memory access, main memory access. Okay, and particularly the block size. Here block size, that means in the cache the individual location we mentioned is the block. The number of block if we increase, So it has some advantage as well as disadvantage both. So most of the time block size is very important parameter. Then you will find the number of caches. That is a very important thing. Multi-level cache or single caches will follow later. So that's I mentioned here. CPU try to always access. See the arrow symbol. You remember. So some cache memory data can come the register, and from register you can store in the cache memory also. That's why multi-level. Again you see the symbol main memory to caches transfer. So these are the access of the, but in this case a CPU can go for the main memory if this data is not found. So my intention that you can draw like this figure like in this also. As I showed. So same thing here mentioned. Is it clear? Now, locality reference refers to a phenomena. This is the very important, in which a computer program tends to access same set of memories. Remember this same set of memory for a particular time period. There is another time period. These two are same set of memory for a particular time period. In other words, root to the tendency of the computer program. That's why I'm telling tendency like human tendency, human psychology. That way I given the story of the your bush or jobs. The computer program access instruction whose address are near one another. Always this is the tendency to one another. This property local reference mainly shown in by loops subroutine call that I mentioned. It is found. Loop subroutine calls in a program also individual access of the arrays. So we found there is a spatial locality and there is a temporal locality. Spatial that there is a chance that element will be present in the close proximity to the reference point, and next time it again searched the more close proximity to the point of reference. Always search the close proximity of the reference point. Now you are searching. This is the chance. There is a spatial locality reference. Since sizes of cache memory less compared to main memory, that's why this is two important point. So to check what part of main memory should be given priority. Why this locality reference? To give the priority the which page will come loaded in the cache decide based on the locality reference. You are accessing now X, but after X which will come or which pages you will be considered and you will give some priority that also based on these two references. If you found at least recently used algorithm will be used. Remember this algorithm, name of the algorithm the LRU. So many algorithms are there, among them least recently used algorithm, that is the replacement policy or replacement algorithm, was mostly used in the cache. In your operating system you will find FIFO, fast in fast out, SJF, shortage of fast, LRO, least recent use, optimal use. So many algorithms are there, but in the cache LRO used. Why? I will explain later. Very soon I am coming to the point. Fault occurs with the word will not only load in the word main memory, but complete page fault will be loaded, because special locality reference rule says that if you are referring any word, next word will be the refer to the is registered. That's why we load complete page table, so that complete block will be loaded. So in the temporal will be the whenever there is a page fault occurs within a word, will not only load word in main memory, not only word, single word. That's why I told that, but complete page fall to avoid loaded, because special requirements are nearby location. That means if you know this the page will be accessed in the location I told, that bank or chunk of memory, or particularly as per the block size of the cache, some pages will be loaded. That means full page, where I told that point, full page will be loaded, not a single page fall, complete page. Okay, in the it happened that in the complete page only that part was, only one data was only required, not others. Are you getting my point? But still even complete page will be loaded. Can you tell me, Concon, why the complete page?
Sir, because special rules, sir.
I asked Concon.
Uh, the complete page will be loaded.
Huh?
So because spatial locality of the reference rule says that.
What does it state? What does it mean?
So if it is present in a nearby location, then
And there is a chance, and there is a chance. I think there is a chance in the page. You know, when a page you are actually half page or part page you are not loading. Why entire page you are loading? Only for that purpose that we assume that in the page now you are accessing the part, and there is a chance that nearby chances will be happen for accessing the data. So that time, but it may happen that most of the time, sometimes it happened that also only that part this content was used, and again you have to delete an entire page will be loaded from other location. Am I correct or wrong? So that's why it sometimes happen that part of the page even you are using may not be required to load it again. Okay, so up to this we understood the cache's preferences, temporal locality. I have given some examples here that CPU is the current memory location, and that the spatial locality references also I have given. So these are the two. So now more than one word are put in word in the cache block to exploit the temporality. More than one word. That is the one point. Why more than one word put in cache? Even you are accessing one word at a time, but more than one for a particular page loaded, exploit the temporal locality for reference in a program, exploit the spatial locality, both are maintained, even reduce the miss penalty and none of the. Now what does it mean miss penalty? First question, miss penalty. One is miss rate or miss ratio. Miss ratio or you can say miss rate. Both are not same. Miss rate or miss ratio is same, but penalty and this part is not same.
Sir, in case we cannot like transport data from one part to another successfully, sir, the amount of time that is lost in order to
No, no,
repeat.
no, 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 no. That is not no transfer cases. Suppose you are searching a page in the cache, it is not found. If it is found, that is called hit. And number of time with respect to the total number of access, the number of time you are accessing the page or you found the page, that is the hit ratio. And number of time you are not getting the page, that is miss ratio. Hit is that the page is found, miss page not found. Just try to understand. Hit page is found, miss not page found. That hit number of hit by total number of page access, you will get the hit ratio. Number of miss by total number of page access, you will get the miss ratio. Is it clear? So miss ratio and miss rate almost same, but the miss penalty and miss ratio is not same. Why not same? Suppose in the CPU you are accessing the cache memory. Okay. Now, when you are accessing the cache memory, suppose the page is not found in the cache memory. So that is count as a miss. Okay. So page is not found. Now, suppose if in the cache you may not found, it will go for the main memory. Now the CPU access from the main memory and the data will be again loaded to the main memory to cache memory. So there is a loading time. There is a loading time and there is also search time in the cache. Clear? In hit ratio, whenever it is searched, it is found. So there will be no loading time. They will get the data. But in miss ratio, there is the additional loading times are there. So to access the main memory for the data and also load, and also load because they are access directly main memory access very slow, and also for main memory to the cache for loading for future purpose, both time will be considered during the computation the miss penalty. So miss penalty, that page is not found the time or searched page in the search in the cache, the total time record in the searching the page in the cache plus the loading additional time due to the miss the loading the page in the cache additional time is required, that total will give the miss penalty. Understood? Student always confused in the miss ratio or miss penalty. Penalty means you are giving penalty for this one. So latency will be increased. In miss ratio is just a numerical figure. Now number of time pounds and this like in this or miss penalty incurs or counts the latency. And that latency, the additional extra latency required for loading the data from main memory to cache and to access the main memory. Because when it is not found the cache memory, it will search to the main memory. Am I correct or wrong? Am I
Yes.
correct or wrong? Because
Yes.
now searching time of the cache memory plus searching time to the main memory plus loading time. Are you getting my point or not? So this is the total latency required when miss happen, and that will is the miss penalty. Clear? So these more than one word are put in one cache block. Among these, which is correct answer?
So reduce the miss penalty, sir.
No.
So, but probability goes higher now of getting.
That I know, that is good thing. But more than one page are put in the miss penalty occurs. Sometimes page is found, then miss
To
penalty will
exploit
never
the
happen. Exploit the
temporal
spatial.
locality.
No, temporal is that.
Spatial
Temporal
locality,
maintain
sir.
the
Spatial, sir. Spatial, sir.
spatial. There's a more than one block around. And temporal is associated with one block. Associate the one word. It may be multiple word or maybe one word, but it will associate at a time only one reference point, which will be accessed frequently. Maybe loop variable, only one variable. Frequently will be accessed. No problem. But the entire memory, like array like memory, is not is addition. In the particular individual location of the array, which is frequently accessed, he bothers about only that individual one page. So more than one word are put in one cache block to exploit the special locality of a reference in a program. Got the point? So in the mid semester, you will get the answer very close to all the answer, but the actual answer will be rewarded. Not at all. Okay, that's right. Fraction of missed memory reference. Okay, I think up to this today we are giving, or I will go for this for chapter. आप लोगों को तो burden हो जाता है जल्दी जल्दी. Can I go up to this?
Sir, actually, we have a class on 3, sir, and we haven't have had lunch, sir.
लंच के बाद मत बोलो. लंच के बाद मत बोलो. ये पहले से हम लोग समझौता कर लिए थे. लंच होगा मेरे क्लास के पहले.
सर आज सर वो तो